Welcome again, everyone, to another episode of Dan Does Data. Tonight we are continuing our study of self-driving car models, but we are looking at a new dataset. You might have heard recently Comma.ai, a startup, I think out of Silicon Valley or thereabouts, is trying to get self-driving cars going, and to help do that, they released a dataset that they gathered themselves of a vehicle going down the highway, I think mostly highway, for about 7 hours, and the appropriate steering angle that they have. So I want to take a look at this data, see how it compares to the, Grand Theft Auto data that we had. This is sort of real data of someone actually driving, you can see here. And they've got a very similar visualization to what I had. Theirs, I think, is trying to predict where you're actually going to end up down the road here, just in terms of how they're visualizing that. But they've got the blue is what is actually happening, and the green is what they're, just a very simple demonstration model, is saying you should turn. So we sort of want to have something similar. They have a paper out which I have skimmed but not read entirely, wherein they do some auto-encoding on the images to figure out good features, and then they use that to build a recurrent neural network, so you look at several frames at a time in order to predict where you should eventually turn. So that's kind of interesting. We're not going to be getting that far today in just an hour. My goal today, our goal today I should say, is just to read in the dataset and hopefully build in some very simple model. Now, one thing, this data, which they made publicly available, 45 gigs of data. If you go to their GitHub page, github.com/comma.ai/research, you'll see the link to the data. I downloaded it, all 45 gigs. However, we're not going to use all of it. For the purposes of streaming, that's not going to be helpful. This computer is going to be way too slow. Hey, Rick, good to see you. You might recall this past weekend I had mentioned it was going to be the first race, and we'll see how much we actually talk about that. Always looking forward is how we're going with this model. We're looking at Comma.ai today, so we'll see how it goes with the other stuff. Right. So I kind of want to just jump into it here. I've downloaded this 45 gigs. I've unzipped it. And it's made up of a few sort of subsets of data. And I would have liked to be able to just download one of those. So they took data on different days from different times. And so I just want to look at this one small one here. It's 3 gigs of camera footage. So that it's hopefully like manageable, we can train at a reasonable pace, and it won't take forever. That's the idea anyway. Rick says, we got on the road, we just need to calibrate. I mean, that's all the model is. We just got to calibrate it right, figure out the right translation. We'll get to that. All right. So what the heck do we need to do? First, we got to load in our files. So what do I have already here? I've got some imports that I know I'm going to need, like H5Py. This is all stored in HDF5. We're going to need SciPy to do some image processing, and whoa, what did I do there? Okay. We're going to need glob just to grab the kinds of files. We need TQDM because I like looking at progress bars, and all our Keras stuff. We're probably going to need some of that. Maybe not today. Hopefully we will. So let's just read in the camera files that we have. I've downloaded the whole dataset. I haven't extracted everything because that was also taking a while. I downloaded it overnight. It took about 4 hours on my crummy internet connection. But the dataset itself isn't too bad. And get the log files as well. The log files are what tell us which way to actually steer. The camera files are just the input for the data themselves. So I just want to read in a little bit of data and poke around and see what the format is. They do have on their GitHub page like an example demo. It gets to be very abstract though. Like you go to train steering model, figuring out what the model they're using in the demo is very simple. That's nice. Figuring out how they get at the data, you have to like go through a few layers of indirection. They build this thing to generate the data. They have like a server that just loads the data as it's needed because there's so much data, so you kind of have to do that. I just want to explore the data myself. I like to do that. That's a fun thing for me to do. And the alternative is trying to read code. And reading code is really hard. That's the thing. It's almost going to be easier for me to figure out how the data is formatted than to try to read their code and understand that. alternatively, because like, well, which part of this code is actually reading the data set? Which part of the code is making it look nice? I would rather just read the code. So I want to say, just temporarily, dfile equals whatever this small one is here. Equals dataset slash camera slash h5. That one. Yep. That's all we want. And I want to say that h5f equals h5pi dot file of the file comma r. Ding, there we go. And now I'm going to steal some stuff from my old shrink script where I used the previous data set and I shrunk it down to something a little more manageable. Okay, that's just X. That's interesting. So this is just all the images that are this 3 channels by 120 by 320, sorry, 160 by 320, excuse me. And it looks like we've got about 20,000 frames here. Not too bad. I've already forgotten how many frames existed in the other data set. I feel like it was about that many. I don't even remember. This blows my mind. That is less than a week ago I was working on that. It was either like about 10,000 or about 17,000. So comparable size data set. So that's actually good. That's interesting. And this type U one, that's so just they're sort of bytes already. So they're already pretty compressed. That is good. Let me do h5f dot. Let's just close that right up. L file for the log file is going to be dataset slash log slash, this should be the same thing. Really ought to be the same thing. There we go. And let's just say A equals the same thing. Not a location ID, invalid object. Oh, I didn't actually open it. Haha. So, let's open the file. Oh, not T file. Nope, 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 nope. L file. We're just exploring right now. So it's okay to make lots and lots of mistakes. Because their mistakes right now are easy to fix. That's always the key. Whoa, okay. There's a lot of things here. A lot of things in the log. I wasn't expecting this much. I thought it was pretty much just the steering and not much else. Okay, interesting. So there's some radar information, some GPS velocity. Oh, that's kind of cool, actually. We have 98,000. So they did mention somewhere in their paper in here that there was a file that would help you line up the log file and the camera file. Cam1 pointer. Right, one of the log HDF5 datasets is called such and addresses the alignment between camera frames under measurements. Yes, so we have a lot more measurements here. You'll notice that this one, UT Cam2 pointer, we've got the same number of frames as we do in the other one, in the actual camera footage data. But this, I'm willing to bet, is 5 times as much. So we're sampling, it's 20 hertz of images, so 20 images a second. So we're measuring something 100 times a second, which is very reasonable. Let's just verify that. That's not exactly on there. That's funny. That is not exact. Where, oh where, how many was it? Oh, 19,731. Times 5? No, it's just not exact. That's strange. That's super weird. I guess I should have known that, you know. Yeah, weird. Okay. Things aren't exact. Well, it could be that we measured a few extra here in the end. Although it's off by more than 5. Okay, one of those things. One of those things we'll have to deal with. So this is lots of information on the car. Let's just real quickly scan through what we got here. GPS velocity, so that you're going to get a 3-long vector, which I'm guessing is some kind of XYZ or velocity in an absolute sense, which is useful, but if you're like cars pointed forward, X, Y, and Z are relative to the Earth, not to you. GPS 2 fix. Don't know what that is. RPM post torque? Nope. Velodyne, self-drive. Is this if you are in self-driving mode, maybe? Damn, I gotta not highlight. That is screwing me up. Speed absolute. So probably you just take the magnitude of your velocity vector. Cam phone pointer. Not sure about that. Brake. How much you're braking? That's kind of cool. We got that information. Car acceleration. I assume that's absolute. Speed. Okay, we actually have the same information that we had in the other models. This is actually good. If I have real, I just saw car accel and speed. And steering angle. There it is. There's the juice. And cam 1 pointer is what they're saying lines up the frames. Presumably there could be more cameras. And there's all this other stuff. So cam 1 pointer is a big one. Steering angle is a big one. Speed. And I'm pretty sure car accel. IMU accel, that's going to give you an X, Y, and Z. Probably from a device attached to the car. But I really just want to know, like, what is the acceleration of the car? Okay, so that's cool. Super good, super good. I want to know about this cam 1 pointer business. So cam 1 PTR. What does this look like? This data set, yeah. That value. Show me. Mostly zeros. Interesting. Not sure what that's about. I didn't import NumPy. That's silly of me. Alright. Does 0 mean it's not associated with any of these? It's anything? I would have thought that would mean it's associated with the first frame. That's what I would have thought, but maybe not. And again, there's 19,731, I thought. Yes. 19,731 frames. But apparently I have, well, there's the 0, which is going to be one of these guys. I don't know which one. That's a little irritating, actually. Would have preferred they're using floats, which is a little silly there for the pointer. But that, again, none of that really matters. Wait, using 8-bit floats? Weird. Okay. I guess that explains why you're not using the sign bit for that. These can't be 8-bit floats. Maybe they are. You know what? I just need to plot this, because I'm going to go crazy trying to look at it. There's 98,000 things there, and I am going to go absolutely bonkers if I don't get to look at it. So let's go ahead and do that. Plot of this. Whatever we got. It's the only sane thing to do. And I've forgotten to hit the Reddit button again. Alright, those numbers are just going up. Did I just look at this wrong? If you want to go to Reddit and make sure other people know about this live stream, feel free to do that. Reddit.com/r/machine learning. Shameless advertising. That's just going straight up. What error is... That's so strange. So strange. Alright. But that is what it is, I guess. That's figure 1. That's so weird. I just want this. This is just what I want. Just give me 100,000 things. You know, so does 0, does it loop back or something? This looks totally normal now. So I could pick any one of these measurements to be the magic measurement for my frame, or you could average them, or whatever makes sense in that context. So I'm probably going to take the last one, or the first one. The first one. I like the idea of the first one. I'll just take the first element of each one. So the first time I see 188, I know that's going to partner with the camera image index 188. Because this way, I can just do numpy dot, is it index? I think that's what it is. Numpy dot index arg. I could have sworn there's like list dot index. Yeah, which is sort of what I want. Search. No, numpy dot find. Oh boy, now this is embarrassing. I thought there was like a find all or something. Maybe there's not. I must be thinking of something else. Anyway, how do you pull out the first index that you've seen of every one of these? It could be that it's constant. Here we see 5, 5, 5. Yeah, as I suspected. But I get the feeling that because it's like not exactly on cut. So occasionally there's going to be 6, occasionally, or there might be 4 sometimes. Because they're not exactly 20 hertz and not exactly 100 hertz capture rate, which is why they need something like this. Otherwise you're going to drift off, which will be really irritating. Oh, indices. Maybe that's what I want. Compute an array where subarray contains values 0, 1, varying only along corresponding. Return an array representing indices. That's not what I want. That's not what I want at all. So where, oh where? Curious how they handle this. Let's go to view steering model. This is where they generate their model. Drop point, drop path, calc curvature. I don't need to do that. They're just doing model.predict. Image, they're saying all the images. Oh, they're just looking it up. Interesting. Even though it's a float? Are they in Python too? Maybe. There's a good chance of it. So they get their particular data set, they get their camera to pull out their image. They open the file as .x. Yeah, and then you grab the cam pointer 1 of whatever image you're looking at. Yeah, whatever image you're looking at right now. That seems... Hang on. This doesn't seem cool. Log times. Wait, what is this? What is that? What is a log times? That's new. What is log times? Ugh. This is the actual time in seconds. This is like 100th of a second. That's 200ths of a second, so on and so forth. And so you see, it's really, this whole thing's going on 987 seconds. So I figure they're probably trying to shoot for 1,000 seconds. And you can see, do a little math, boom. 15, 16 minutes of driving is all they're doing. That's all the data we have with this 3 gigabytes here. So you're pulling out the particular camera value from the particular eye. Skip times 100. What is skip? 300. You skip the first chunk of data, and you go as many times as you have. This is interesting. And this is for the full like 100 hertz worth times 15 minutes. So they're skipping the first couple, I don't know, maybe 2 minutes, 3 minutes. Oh, 100 times that. They're skipping the first 30,000? Interesting. I guess that's just where they wanted to start this particular viewing of the steering model. You skip the first 30,000, you got like 68,000 left. And for each one of those, they're saying given this speed to type information and the same image, from the audience, we need an AI-controlled laser cannon on the car too. But what did I tell you guys about killbots? An AI-controlled laser cannon. Oh my goodness. Because it can't be a regular cannon. It would have to be a laser cannon or like a flamethrower or something ridiculous like that. Okay, so they're showing the same steering information for all the various speed information. So they're assuming you look at the same image, but my speed has changed a little bit, my acceleration has changed a little bit. That's interesting. That's worthwhile to consider. I don't have that fine of control over this vehicle anyway, so I actually, I want to iterate through the images, just that, and pick one of the speeds that I've got and one of the accelerations that I've got. I think that's what I want to do. So we need to go through let's see. Cams equals h5 pi.file. Cam file is 1, I believe. Because I'm sorting it, because I'm doing the right thing this time. No, cam file is 2. There we go. It's actually the yeah, because it's the 31st. There we go. Where is, oh, that's all. So if I were to do this, hypothetically, will this fill up all my memory? Will I crash my computer in the stream right now? That's sort of the question right now. Because it's 3 gigs or so when it's in this H5 Pi format. We'll see how bad it is here. I probably shouldn't have asked her. Oh no, that's fine. So yeah, about 3 gigs. So that's not too bad. And we're gonna do some reformatting so that it's like 64 by 64. Meaning we're gonna have to lose like what, 60, 70, 75? Hang on. No, 80. We're going to have to lose 80 pixels on each side here. Right, because that's twice as large as this. That math would have been much easier. We're going to cut out the edges, the widescreen format, so it's 160 by 160, and then just scale that down to 64 by 64. So we're cutting out half the image, and then making it, call it half as big again in terms of area. Well, a quarter. So it should be about 1/8 the size. So instead of being 3 gigabytes anymore, like 500 megs, maybe 400, depending how well that goes. And then it'll be much easier to cart this data around. I can easily load it in, and if I really wanted to, I could apply this to all the other data sets, and it'd be much easier to hold all of them. And so it becomes easier to play with, quicker to iterate through my models. Okay, well that's cool. Logs. It's log. It's log. It's big. It's heavy. It's what you guys don't know. It's log song. You really should. I don't want just want logs. Speeds. Speed. Gosh, now I have to remember exactly what it was called. Okay, not there. Log. Where is it? Oh, I can just say A. That's right. A. Speed. There we go. Just speed. Speed and carousel are the guys I'm interested in. Oh, and steering angle. Right. Speed. Cell. Carousel. And of course, oh, I don't need to open this as a file again. Derp, 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 derp. Well, logs. Speeds equals logs of this. There we go. Seeing it live as it's happening, folks. And over here, not steering torque, steering angle. Angle. Yes, just steering underscore angle. We'll just call that steer. Okay, perfect. Steering angle. Getting used to the data. Reading the data, as always, half the battle or more. But we're making some progress here. I've got the cams already. Got this. Unable to open object. Object speed doesn't exist. Really? Did I misinterpret that? Is it part of something else? Speed. I could have sworn that it was. A.keys. And I see speed right there, buddy. Right there. So I think speed does exist. I think you're lying. Looks fine to me. So what's logs? Wait. Oh, hang on, hang on. Of course. Dict, whatever dot items. I see. I'm using this inappropriately. I don't have a ton of experience with H5Py. I thought I understood it though. I thought I could just... Yeah, I thought you could just do that. Oh, and you gotta say the ones you want, maybe? I didn't think you'd have to do that. Logs dot... I say logs dot keys, because they're just opening the file here. But I can't say speed. I really can't. Unable to open object. Object speed doesn't exist. That's so strange. Yeah, cam1 PDR? That's strange. Could have sworn I could get away with that. Apparently that is not the case. Log files, not cam files. Not sure what you're getting at by the log files versus the cam files. Am I using the wrong? No. Did I load that wrong? Let's see if I loaded that wrong. I did. Thank you. Thank you very much. I would have been fighting that for who knows how long. And it should still be the second one of those guys. Yep, 31st. Thank you, Gustavo, very much. Stupid mistakes that I'm going to be making. There we go. Look at that. Speeds. A cell. And steering. Okay, but we don't actually want all of these, because I need to get the pointers as well. Cam1 pointer. That's the important thing I need to get. And then I want to say the first time I see a value in the pointer, I need to associate it with that index. Cams. Did I say length cams? Is that a valuable thing? That is. Okay. N frames equals length of cams. Take a look at that. And then what is going to be the best way to do this? I think I have to scan through. That's my log pointers. I want to say starts equals numpy dot zeros of n frames long. Here's what I want to do. I in range n frames. We're going to start at 0. Or we're going to say current equals 0. We're going to keep track of where we are in the big array. And what do I want to do? I want to say that for I in range n frames. Yeah. It's got to be pointers for j in range from I up to possibly n frames. We're not going to go the whole way. We're in fact only going to end up looking at each point once. Oh, you know, I need to say if pointers I int pointers I equals our current. And I want starts of I, right? No, I need to, all right, hang on. P in pointers. There we go. If int P, losing track, am I? In the wrong mode. Equals current. Starts of current equals P. Else, there's no else. Cur plus equals 1. So when we find the first value we're looking for 0. They are in order. I did check with that real quick. So it's going to look at them in order, and as soon as it finds the first 0, it's going to stuff that in the first position, and then it's going to start looking for the 1. When it finds that, it stuffs it. So this is a nice linear thing. We're not starting from the beginning every time. We've read Joel on software, an algorithm that sort of does something but always has to start over from the beginning, even though what you want to do is somewhere in the middle or at the end. It's a Schlemiel the painter algorithm. So we've avoided that here. We've done a very minor optimization. Bing! Look, took no time at all. Starts. I wanted those to be integers. I really wanted those to be integers. NumPy dot, how many of these do I got? UN16? Yeah. There we go. Starts. Bingo. Yes. Okay. That is good. And if I say set list starts, and I ask how long is that, I should get the same. It should be all unique. Yes, it is. Okay, good. Actually, hang on. Something's weird here. Like, this should be a value around 98,000 or something. That is not right. That is not right at all. What is P in this world? P is of course 0. Of course. But pointers of, I don't know, -10 to the end. 20? -100. There we go. I wanted this the other way around. Oh boy, one of these days. I have successfully recreated a range, I imagine, of let's see if I just recreated a range. I have a sneaking submission that I did. Yes. I just created a very fancy way to make a range. Isn't that grand? Okay. I wanted to know the correct P index to pull out. That's what I wanted. I wanted a list of P indices in order. So I don't really care what the p-value is, right? Yeah, because I know they're going to be going in order, so I just need to be doing that. I need to know, I need a list of the correct frames, is what I need. So let's do that. Okay, starts. That seems wrong a little bit, but it's better. This goes up to like 33,000, which I find strange, given that over here we're at 19,000 something. Very odd, very odd. If I go to pointers of this thing, what happens? See, that is not at the end. What is cur? Something went wrong here. And again, just trying to read in the data. Half the battle, half the battle. I could just use their pre-provided, or use all the data and use their data server example kind of thing. But I don't want to do that. I want to understand the data myself and just use the data that I'm interested in, make sure that I'm looking at the data and not getting my left and right confused. If I can't open the data and make a model myself, then I shouldn't be trying to build a model just based on their sort of prescribed script. So what is wrong here is the question. Starts are just a list of zeros. I'm walking through the list of pointers, keeping track of which pointer I'm looking at. And I'm saying first, I want to look for the pointer to 0. Wherever I find that, store that off in my starts. Okay. And if I find it, I store that index in my list. I don't care what the pointer actually was. Or do I? Should it be starts of P versus cur? Those ought to be, well, they're the same thing. P and cur are the same thing when I'm storing it, so it doesn't matter which one I use. And then I increment cur. Hope it's not like cafe. Yeah. Well, their model is abstracted, but it's all in Keras. We'll take a brief break from staring at that. At least the model that they have in their demo code is all in Keras. I don't know in their actual paper what it was in. So they're using pretty straightforward Keras stuff. Their simple model of read in the image, do some convolutional layers, and then do a couple dense layers. And by a couple, it looks like one super wide layer, and then an output. And it's just mean squared error because you're just trying to get a real number. These are somewhat beefy convolutional layers. I was talking with Isaac recently over email, who had helped out with the model a bit last week and before. He had a suggestion of use a pre-trained set of weights and model for general image recognition and sort of use that as the beginning part of your layer, or beginning part of your model, to like parse these images sort of, a little bit of pre-processing, and then you have some layers underneath. I thought that was an interesting idea, and maybe I'll try that at some point. But today I just want to look at some data. That's all I want to do. And I don't understand why this is not working here. That cannot possibly be correct. Current. No, but we're setting it equal to I. So we're failing out early. We're going through all the pointers here. I'm not resetting I. I'm enumerating. What is P? 0. Of course, P 0. What's I? I is all the way up there. Like, I fully expect to get up in this region. And like, it's going to get to the end and it's going to be wrong. And that's fine. I'm okay with that. If I'm missing something really obvious, do feel free to shout and tell me I'm an idiot. Because that means we all get to learn. So, that would be great if you can do that. God, this is really irritating though. It's like, why is this not obvious? Alright, I want to try something silly then. If I take every fifth, no. Oh, hang on. I might have an answer. Maybe. It might not start for a while. Oh, no, it does start. 1, 1, 1, 1, 1. Okay. And it looks like those are all relatively normal. Start there, maybe. start at 30, 40, 50. So if I start at 45, no, 40. Start at 37. Yeah. And you ask for every fifth guy. What do you end up with is the question. Do you still get everything? Is it really just every fifth? Or do you have some nasty repeats? 8 of 10. What's the end here? Just want to look at the last couple. So we get 5 in the end. So let me chop off the end. Negative 50. That should... Oh boy, what the hell happened here? What? Alright, fine. Only lost 25. What? What in the sauce is going on? 25 by 5, you know? 25, yes, that's, I can't add. It's alright. Length of a set of a list of all that. This is just every 5. 1721. No, we're short a couple. That's not going to work. I thought maybe I could just take every fifth. Can't do that, though. I appreciate that they included the pointers array. It appears, however, that I am just an idiot and can't determine how to use this the correct way. Did I not reset current? Was that the problem? Perhaps? Starts? No, that wasn't a problem. And this is looking like generally correct. Like, oh yeah, that's 52, then it's 5 later, and I see 5 later, and 5 later, and 5 later. Like, if I look at pointers from here to here, those are not the values I see, right? There's a serious disconnect here. Sure, you start at position 52 or whatever. But that's super weird. Also, starts of 0 equals 37. We'll set current to 1, in fact. I highly doubt that's what the problem is. Yeah. N frames times 5. Somewhere there's like a stretch where it's, you know what? Plot starts. Somewhere it decided to restart. I don't know why that is. Which is weird, because currents should only increase. So I've done something super wrong here. Oh boy, oh boy, oh boy. Things are hunky-dory until position... What is this position? $13,099? $13,099. What's weird about that? Nothing strange there. That's super duper strange. And again, if you plot just pointers, it's a totally normal looking graph. Just go straight up. And like, yeah, it crashes at the end down to 0, but who cares? That doesn't matter. Cur right now is at the end. And length of starts is as it should be. let's walk through this. Is there a pause? Is that a command? I forget. No. Python pause. No, that's not really what I want to do. See, I don't want to sleep for a second. Nah, that's silly. Alright, we'll just do this. Except we are going to print some input. We're going to say cur 0. Format cur. That's all. I just want to see this walkthrough. And I just want to turn off my auto indent. That's all. I really need to turn off the TQDM to make this work. This is starting to irritate me that it's something so silly is throwing me off. And I'm sure it's the kind of thing that there's a lot of ones there. Oh, right. 7, 8, 9, whatever. Could always use good old print statement as debugger. Yeah, that's basically where we're ending up. I could use the Python debugger at some point. This is silly. All right, that's going to take a long time to get somewhere. But like, it looks like it's going normally every 5 or so. So why, oh why did things go wrong here? Oh, was it not auto-indenting correctly maybe? Maybe that's the problem? No, that wasn't the problem. Okay. Well, that was worth considering. That's what the problem was. Am I using the wrong place here? Maybe. No, because current is... I just need a damn list of indices from speeds and Excel to pull out. That's what I'm looking for, and that's what the I is. It's the index of whatever pointer value I'm on. What if, I mean, can I grab the last one, maybe? Starts as D-type UN16, wrapped around 65K? Oh, you know what? That's going to be exactly correct. That is exactly going to be the problem. UN32! That is because, in fact, 2 to the 16 is 65 thousand. We're like at 98,000, which gets us about in the right neighborhood. Oh, stupid rookie mistake. Watch this. Sorcery. Thank you, Stefan. Stupid mistake, stupid mistake. Should not have taken me 15 minutes to solve. And I should have noticed it right away when I saw the stupid graph of it going up and then suddenly dropping and continuing on up. Alright, now then. Let's grab those guys of interest. Speeds. Plot of speeds. Okay, speeds vary from 0 up to, these are like miles per hour maybe? Who knows? We'll find out. And they got some speed cycle changes, fast and slow and fast and slow. This is, you're stuck in traffic. You're going to go somewhere. It's okay. You got to hit the brakes. You get to accelerate again, and you're going along okay. And you slow down to a stop. All right, so that's interesting. And just to prove, we only have the ones we're interested in. Yeah. Okay. And we'll look at some acceleration as well. Almost, almost. There we go. As always, the danger of doing things live here. So this acceleration includes places where we've definitely braked. We're slowing down here a whole lot. In fact, we're speeding up, slowing down, speeding up, slowing down, speeding up, slowing down. And then we're kind of at a cruising speed around here. We sped up a whole bunch, and then we're just kind of cruising. We slow down a whole bunch real quick. So this is basically the derivative of the speed, as expected. And our steering, I want to take a look and see what that looks like. We got 10 minutes. So this is not super exciting steering. I'm not sure how this is, what the units are here either. I do want to see, what does this look like up close? Because clearly they're turning dramatically in certain places here and not in others. So they're kind of, just fiddling a little here, a little there, a little here, a little there. Not too exciting. Cams, however, I need to say plot.image show cam 0. Is that going to be the right thing? Yeah, nope. Transpose of, what do you think about this? 1, 2, 0. Right? Yeah. Not quite. Unless it's totally dark, which is a possibility. Let me get one in the middle. Yeah. Alright, that's actually vaguely correct. This looks like a picture of somewhere, something. It's wide. Is this something else? Okay, this is a road. This is definitely a road we're looking at. So this is now normal. Okay. So let's see if in the next 5 minutes I can chop out the left and the right. We're only looking forward. That's just the way things are going to be for the sake of this model to simplify things a little bit. So in fact, we should strip down cams to 64 by 64. So where do I do that in his shrink? Because I do essentially the same kind of a thing here in shrink. I believe it's already in red, green, blue. I don't think I need to fiddle with that. Let's look at 1 or 2 more samples just to. It doesn't hurt to look at a few more data points here. I mean, it's dark. Brake lights are red. It's going to be interesting that this whole thing's in the dark. Maybe earlier on it's not in dark? No, it's dark. Oh man. Wow. Did not think it was going to be this dark. 300? Oh, are they still in the garage here? Oh man. Right, that's why they have this skip, I bet. Okay, then they're pulling out like a local street. And it's just night. That's it. It is what it is. What is this? Oh no, they're on a highway here. Cool. That's super neat. All right, I apologize. I'm just like yeah, they're backing up out of the garage or something. That's funny. That's very funny. Very funny. Oh man. This is imagery size stuff. Right. So 4C in cams, and I want to say simple or small cam, numpy.zeros of 3,64, and z-type equals float 16 is fine, right? Yeah. We wanted floats for this for whatever reason. Oh, for the computational purposes. That's a bat cave. Yeah, good comment, yeah. These guys maybe in fact be Batman. Batman has a self-driving car, so it could be true. Alright, so I'm going to double my size by using float 16s here. So I'm going to get burned on that. But I'm going to save in other places. We'll see if I can get away with this. If it weren't, you know what? Screw it. Uint 8. Uint 8. Int 8. There we go. And it's going to be length cams, end frames. There we go. Grab this. All right, if I can get this camera thing sorted out, then we'll call it a win. Cams, not shape. Yeah, there we go. So, what do I want here? I don't even need that. I just need smcam.ai, and I just need that here. I comma this, and enumerate. Usual thing, enumerate. So I'm afraid we're not going to get to the machine learning stuff tonight, but this is Danda's data. So fiddling around with the data is, as I've said before, half the battle. If you can't look at the data, then you can't really do the problem and feel like you understand it. See, but we're not using all of it. I want all the channels, all the rows, and I want 80 to -80. Cut out 160, the 160 center points. Let's just take a look at that. Okay. And transpose. I don't think I have to do that here. I think this is already in that format, so I'm not going to do that for now. We'll get around to that when we get around to that. And I want to slap a TQDM around this, because I'm not sure how long this is going to take. Alright, so it's a bunch more memory locked up. RGB 6464. Let's give it. Could not broadcast. Ugh. So I do have the transpose. Okay. But SMCam is the same size. Curse you. What is C though? C.shape. SMCam.shape. Did I misinterpret something here? SMCam cam 0.shape 36464. Cannot broadcast input array from shape 64643 into shape 364. Oh, so I guess imagery size just does that. All right, fine. Fine. Dot transpose of 2,0,1. And I believe that's what I was doing over here. Yes. Okay. Alright, so I know that there's about 19,000 iterations. We're about a quarter of the way through, so this won't take very long. Just a total of maybe 20 seconds. So that's good. So even if TQDM doesn't have a length, because of the enumerate argument, it can still tell you how many iterations you've done and how many it's doing a second. smcam of 0. Okay. Plot.im show smcam of, not 0, of like 10,000. 1,000. Yeah, 10,000 is fine. Invalid. Right. And I got transpose, as always. Sorry for not paying attention. Yes. So just for reference, that's an interesting shot of the bat cave, as was determined, of the actual data. And then of the compressed data, you're just sort of looking at a zoom-in picture. But you're saving yourself a whole lot of effort. And that's all the things we need, right? That's the speeds, the acceleration, the steering. We got to do some rescaling still. That's not going to be too hard. But I have no doubt that we can do that. And we've got the data ready, which is, maybe it's more than half the battle. Maybe it's like 90% the battle. It's just fighting with data. We've got our image of the super secret Comma.ai bat cave right here that we'll probably have to skip when we get to actually training the model, but we will actually start training the model next week. Want to build a silly, simple model first, and then maybe we'll try some of these interesting other ideas on how to handle the model. Maybe we'll try Like Isaac's idea had something interesting. We'll try what Comma.ai has in their paper. If you have an interesting idea, feel free to send it in, and I'll see if I can implement it. Or I'll see if I can totally misinterpret what you state and implement something different. And maybe that'll be fine too. But that's all we got for tonight. As always, stay safe in the data mines. Have a good night.